So today I'm going to share with you a little bit of how you would go about starting to build an application with Clojure. I will try to make it interactive. So in that spirit, I will have this REPL here, which is online, and you can try it. It's try.clojerl.online. You can try out the expressions there if you want to as well. So let's start with what is Clojerl. As Brian said, Clojerl is an implementation of Clojure, the language that runs on the Beam. And some of you might already be familiar with it, some of you might not. So I would like to first give a brief introduction to Clojure and how it works or what it provides. The first thing, top level thing is its syntax, which is very simple. Clojure is a Lisp, and as a Lisp, expressions are lists followed by symbols. And if we want to copy and paste this here, this that we have is a function call. But if we copy it here, we don't get anything because, well, we get an error because function is not defined here. But if we use a function that actually exists, like the plus function, then everything works as we expect. The organization of Clojure code is around namespaces. Namespaces are similar to modules, and they hold a set of bars, and bars can be either values or functions. And it's a good mental model to map namespaces to Beam modules and bars to functions, because when everything gets compiled to Beam code, that's what they are, basically. So in that spirit, the plus function actually lives in the Clojure core namespace. So if we do the same call that we did before, we get the same. So if you want to refer to a bar in a fully qualified fashion, you use the namespace / the bar. And if we want to call an Erlang function, like for example, the plus function, then we do the same. So one of the main design goals of Clojure, the original one, was to make interoperability with the host platform as easy as possible. And that's the same design goal that Clojure has, to make interacting with the Beam as easy and as painless as possible. The main data structures that we have in Clojure are lists, vectors, maps, and sets. A list is a linked list of expressions, but if we were to write this, then it would be interpreted as a function call where it expects one is a function, which is not, so we have to quote it. This is something that Lisps, like a pet peeve of Lisps. Then we have a vector, which is an indexed, ordered collection. I'm losing focus on this window. And then we have maps, which are, we all know what maps are, but these are not Erlang maps, they are Clojure maps, and we will see the difference later. And finally, sets, which are like an unordered collection of unique items. Something that I would like to mention as very specific to Clojure that make it special is these tools for creating abstractions, macros. Every Lisp has them, and so does Clojure. They are for metaprogramming, for treating code as data. And then we have protocols. If you know Elixir, they are very similar to Elixir protocols, or something similar is like Java interfaces. A protocol is a set of functions that then types can implement based on what they want the protocol to mean for them. And finally, we have multimethods. A multimethod is a single function that has a bunch of different implementations, and the implementation that is chosen is defined based on the return value of an arbitrary dispatch function that you can specify for that multimethod. We won't go very deeply into these today, but they are worth going into. So Clojure is very close to how Clojure works. So if you go to the documentation of clojure.org, you will find that very useful for figuring out these concepts for Clojure as well. So that's a very fast and specific set of things about Clojerl, and I would like to share with you how you interoperate with the Beam from Clojerl, because if we want to create a Clojerl application, we can reuse the Erlang or other Beam languages, libraries. So it's very important to know how to interact with those so that we don't have to start from scratch. So in Clojure, as I mentioned before, a namespace is what groups bars, which can be functions or values. And the way that you declare a namespace is with the init and s form. So here we declared and created the namespace, and also we changed into that namespace. It would be the same as doing module example, except that from the Erlang shell, you can't actually create modules. And then if we want to define the ID function that takes an argument and then returns the same value that it receives, we do it like this, and then we can just call whatever that function with whatever argument we decide. So this specific thing is called a keyword in Clojure, and it just translates into an atom, because syntactically and semantically that's the same thing that a keyword in Clojure is, something that represents its own, that has its own value. And Elixir does the same syntax, just as a plus. Anonymous functions you declare with the fn, and here we see the representation of printing that value, but we can actually call this anonymous function by wrapping it around this parentheses, which we mentioned that a function call is how a function call is built. And a Clojure anonymous function is the same as a Beam anonymous function. They are equivalent. So if you want to, for example, get only the odd numbers of a sequence of numbers, you can do odd like that, and then we generate a list of numbers with the Erlang function, and then we get the odd ones, and we can get the even ones as well. So just to make you, to give you examples about that. The way that you go, so I mentioned that a list in Clojerl is not an Erlang list. So if we do Erlang is list with an empty Clojure list, it gives a false. But we have this specific function in Clojure core, which was added for Clojure to convert Clojure data structures into Erlang data structures. So we would get that. This is what the representation of an empty Erlang list. So you can do it like you can get an Erlang list like that, or you could just use the hash Erl and then the list, and you would get the same result. You could do it for tuples, for example, or for maps. This needs to be, and you can do it for sets, because there are sets, but there are no literal sets in Erlang, so we don't provide that. If you call the CLJ to Erl function with something that doesn't implement or doesn't have a conversion, it just returns the same value. We also have pattern matching in Clojure, and this is essential because we have to interact. It is necessary to interact with OTP callbacks and that kind of thing. So that was something that Clojure, like in the JVM, doesn't have pattern matching, but Clojerl adds it. These that we see here, let, fn, defen, case, and loop they are called special forms, but you can think of them as keywords in the Clojure language, and they are used for different things. As we saw, fn is for defining an anonymous function, defen is for defining a function in namespace, and let is for binding values to symbols. For example, if we do this, then we return the value that we bound to x, and that's 1. But if we, for example, wanted to bind or pattern match X with 2, we couldn't do it because this this form doesn't allow for values to be on the left side. We can do it if we change that let for, we add a star, and then we get a bad match because 1 does not match to 2. If we want to do a function in the same, if we want to create a pattern matching function, for example, we would create the first clause of the function like this, and then the second function, the second clause of the function like that, and we would, I did something wrong, Nate. Parentheses. So what I missed is to actually add the star to the function. I keep losing focus on my window. There. So if we now provide 1 to this function, we get 1. If we provide 2, we get 2. And if we provide whatever else, we get function clause. So the rule is that for any of the Clojure special forms where you have bindings, if you add a star, you get pattern matching in Clojure. So message passing and processes, you can use the regular Erlang functions because they interact with the other ones. For example, if we want to spawn a new process that doesn't do anything, we can just provide the anonymous function that takes no arguments and does nothing, and then it will be a process that gets spawned and dies. We can also send messages to our processes. For example, if we send the message to the init process, which is part of the Erlang VM, it won't do anything. It will just send the message, but it probably can't, doesn't expect that kind of message, so we will just discard it. And finally, we add in Clojerl the receive special form, which allows us to receive messages, like as in the OTP sense. So we can receive anything and then print it, but we won't receive anything. So we do a timeout. We add a timeout clause, and then we return timeout when it times out. And that's what we get. So I've gone through all these things so that you have them in your mind and you know that they exist, and you can have an idea of how to interact with the Erlang VM through Clojure. And you can try a bunch of different things here on the REPL by yourself. And if you have any questions, you can ask me or ask in the channel, in the Erlanger Slack, in the Clojure channel. So up to here, does anyone have any questions or any doubts that you would like to? Because I went very fast and probably someone has some specific questions.
I got a really basic one. This it looks so fun. But I was just trying to do Erlang well IO format and give it an argument, and that particular function takes lists rather than binaries. So when you have a string, yeah, you
would do like this, for example, and then you have to provide a list, an Erlang list, and then you say whatever.
Okay. Yeah.
And then, so something that is worth mentioning is that there's in Clojure there's nil, which gets translated into, if we print it through IO format, it's actually the atom undefined for Erlang. But we handled it specially because so we need to handle it specially because in Erlang both false and nil are falsy. Any other value is true, truthy, basically. So yeah, any other question?
I have another question.
Yep.
So okay. So is this a way like converting those messages to Erlang list to imagine that you have running a Clojure script and some Elixir code in the same beam? Is that the way to talk between those codes? through the Erlang syntax, or is there a way to talk between the two languages directly?
It depends. So you would have to, it depends how the communication is done. You can go down into, well, down. You can communicate with Erlang data structures because that's a common language between both Elixir and Clojure in terms of data structures. Both Clojure define and Elixir define their own type of custom types, which are like in the case of Elixir, there are structs. In the case of Clojure, they are just the types, even though they have the same form because they are both maps that are tagged. They don't interact with each other, so they don't have the same interoperability at that level. So the interoperability is mostly towards the Erlang and the Beam level, not so much the abstractions that other languages build on top of that. Right? I don't know if I expressed myself clearly.
Yeah, thanks.
Cool.
Are there any Clojure features that you don't necessarily support that are normal in normal Clojure you found? Besides all the job interactions, but I mean, any language features?
So something that is not included at the moment is hierarchies for like ad hoc hierarchies for multi-methods, because they are a little bit complicated to hook into the current way that multi-methods are implemented. The other thing are reducers. So even though they are implemented, they are not performant enough because there's fork join in the JVM, which makes everything nicer. But those are very specific things. Maybe reducers people can live without. The other thing that is not included is that so vars, the way that vars work is that they are in Clojure JVM, they are loaded when the JVM starts. In Clojerl, they are just functions that have static values. So for example, if you do the following, if you do like Erlang make ref, it will tell you this, Erlang make ref. This is what I was trying for. So the init value, for example, x is not literal because vars need to have static values. You can't just assign arbitrary values that you can in Clojure, for example. That's a limitation and something that works differently. You can work around that, but still it's different. So there are some differences, but most of the semantic way that Clojure works is there, and most of the features are there as well. So there is, if you go to Clojerl.org, there are some like available features, and there are things that are missing here, and things that are not, well, some things that won't be supported, things that are not implemented, and things that are already implemented. So you can get a better view. Also differences with Clojure as some specific differences with how everything works, which one of the things there is this thing is mentioned. But the goal was to make Clojure as close to Clojure so that you can then port existing Clojure libraries. So thank you for the questions. We can take the rest of the questions later, and we can now move on to the part where we develop something. So the developer environment has two minimum requirements, which is Erlang OTP or newer and rebar 3. And it is a good idea to have the rebar 3 Clojure plugin because as installed, so you need it to build a Clojure application, but it's a good idea to have it installed as a global application, global plugin, sorry, because it will give you templates that you can then use to not start from scratch your application, or eScript, or release, or library. There are currently four available templates. So the way that you configure global Revbar 3 plugin is you edit your Revbar config, and then you add it like that. It's published in hex, and so is Clojerl, so you can download them from there. So I have that installed in my machine, and then as an IDE, what I use is mostly Emacs with Clojure mode, paraded, and Rainbow delimiters. Clojure mode gives you syntax highlighting for Clojure. Paraded gives you manipulation of delimiters, and Rainbow delimiters is a nice thing to have because it allows you to visually find what parentheses go where. And VS Code is also extremely nice lately. I mean, in the past few years has become quite nice. But I haven't used it that much. But I know, and I've used Rainbow brackets and paraded. And I think Clojure syntax highlighting comes out of the box. And then something that is nice if you're interacting with an Erlang library is to have LSP mode with Erlang LS, which is supported in both of these and probably more editors and IDEs, but I haven't used it with any other. And in parallel to this, it's good to have a REPL or a terminal where you can compile and do your things there. So our first application is going to be an Echo HTTP server. It's very simple because we need to have something that we can do in the amount of time that we have available. So let me start a Tmux session. And so since I have the Revbar 3 plugin, ignore this. I don't know what that is. I upgraded my Rebar and it keeps telling me that, but let's just ignore it. And since I have the Revbar 3 Clojerl plugin, we get the list of we get included in the list of available templates: the Clojure app, the Clojure script, the lib, and the release. We will use the Clojure app template, which we will do. We will create our Echo project, and then we will do. We will check the tree. So let me do it again. Is the size of this fine, or should I make it bigger?
Looks good to me.
It's good, yeah.
Cool. So what we get in the generated template is license, README, standard stuff, and then we get a Revbar config. So the goal of the Revbar 3 Clojure plugin is to reutilize as much of the infrastructure that Revbar 3 provides as possible. So we include Clojerl as a dependency, and we also include the plugin itself so that we have it available regardless if we have it installed later on globally or not. And as you can see here, Clojerl is just a dependency, though the original Clojure was also sold initially as just a dependency that you can include in your JVM or Java project. And yeah, so I copied that script basically. And so as part of the directory structure, we get the source and we get a test. We also get the Echo app source. So this is what we, as in any Clojure and any Erlang application, need to define our OTP application, and we use it in the same way in Clojerl. So this is an Erlang file. I tried to make the plugin to convert into some special syntax into this, but Revbar 3 doesn't have a hook for that. So for now we use the regular app source file from Erlang. And here we add the description, the applications, and we specify a specific module with which the application is started. As you can see here, as I said before, namespaces are mapped into modules, and the name of the namespace is just the atom of the name. And the convention is that for each dot, that before the last part of the name of the namespace, you create a directory, and then you get all the definitions of each namespace. So I'm going to put Emacs here, and I'm going to open this app.clj file. Here you see the declaration of the namespace and the name, which is the same atom that we saw before. And here this what it's doing is adding an alias for this namespace inside this namespace, so that we can then call just when we want to refer to any function or bar in the other namespace, we have a shorthand like /startling. And as if you remember, these two callbacks are the callbacks for the application behavior, application OTP behavior, basically. And so this will end up being just Clojure function. This will be a Clojure function, an Erlang function when it gets compiled with 2 arguments that will then call the other function that starts the supervisor. And so does the stop, that doesn't do anything. It's just that does that. If we open the soup namespace, we get the start link, which is not part of the supervisor OTP behavior, but we use it generally to just call supervisor start link with the correct arguments. This is an Erlang tuple. This is the atom or the name of the supervisor, and these are the extra arguments that we use. And then in the init, we just build the supervisor flags and the child specs with just an empty list. And these are the default values in general for the supervisor flags, but we just provide them for clarity. And we just return the thing. So all of these is as you would create the same in Erlang or in your language of choice for these specific behaviors, but through Clojerl namespaces. So we can compile this now with the Rebar3 Clojure compile, and we will download the Clojerl dependency, and it will compile Clojure. So since Clojerl is a dependency, you will have to download it and compile it the first time, but compilation is incremental, so it won't have to compile it every time that you change something. And I can show you how that works. So once this gets compiled, we have something that is working, and we can check that by running rebar3 Clojure REPL. And then if we want to start our application, we provide this argument, which is apps echo, which imitates how rebar3 shell works. And then if we want to check what applications are running, we can use which applications, and we get this wall of text, which we don't want. So what we do is we map through every value in that list, and we print a line for each of them. And here we see that we have the echo application running, Clojerl compiler, and all the other applications that we need to get this working. So now we have something that works, but what we want is an HTTP server. And for that, the thing that I use the most is Cowboy. So how do we use Cowboy from a Clojure application? We just add it as a dependency in our Rebar config, and we also add it so that it's started in our app source. So these are regular things that you do in any Erlang application as well. So now we recompile everything. So if we run Rebar3 Clojure REPL, it depends on Rebar Clojure compile, so you get a compilation. But the only thing that gets compiled are the things that weren't compiled before. So if we do this again, now we see that Cowboy, Ranch, and Cowlive are started as well, because we added those. No magic there. But what we want is to have something that if we do request, and we provide some request body. Then, a body for the request. Then we get back as the response the same thing. But now we have nothing listening in that port. This part, configuring Cowboy, is a little bit involved because Cowboy has a specific specs, a specific format of values. But the gist of it is that you do start Cowboy here, then you define that start Cowboy function, which takes no arguments, and then we have to call Cowboy start clear, which means clear text, well, and not clear text, but HTTP and not TLS HTTP. And for this, since it's a little bit involved, I have prepared beforehand the code that goes here, and we can go over that after I copy and paste, like a good programmer that I am. Oop. And here we go. So let me move this. Oh, I can't. Okay. So here, what we have is the start Cowboy function, which is the one that we defined. And here is a call to Cowboy start clear. And what Cowboy expects is the name of the listener and then some transport options and protocol options. The protocol options are the dispatch table, and that dispatch table gets needs to be compiled, and it expects a specific format, which is basically this one here. So we define the value for the routes as a Clojerl value and a port, which is integers in Clojure are integers, Erlang integer or Beam integers. And we define it like this because otherwise we would have to do like hash Erl everywhere, and it gets a little bit messy. So instead of that, we feed in. So for those of you who aren't familiar with this threading macro, what it does is just a macro that rewrites this expression. So instead of doing that, doing the following, which is this, and then it just reorders the calls of the things that you provide to it. So it's like the Elixir. So Elixir took it from here, basically, from Clojure. Or maybe Clojure took it from somewhere else, but the first time that I knew about this was from Clojure. So what we do is we feed routes into clj.erl function, and then we feed the result of that into maps to list. The reason for using maps to list as well is because start clear actually expects a prop list, and if we do maps to list, then we get a prop list, which is convenient. Then we compile those routes in the dispatch table, and we do the same for the port or the transport options. We just convert Clojerl map into a prop list, which is port and option. Here we could have just done, because it's smaller, we could have just done like the literal Erlang stuff, but I wanted to show you how you could manipulate this here. So what this configuration is saying is that Cowboy should use the module or namespace echo root for handling requests to slash. So if we start again our application, you can see that app.clj was only compiled. And if we try to do a request, we get a 500 because, as we see here, the reason and def echo root init. We haven't defined the echo root namespace. So we will define it now. And we will save it in, this is very small. And I don't see the part that's behind. So this is it was created here. So here is root. And the only callback that Cowboy requires is init, and which gets the request as the first argument and a default value, well, not default, but like a custom value as the second argument, which is the one that we define in the routing table. And it should return a tuple with OK, the new request, and some state, which we don't provide anymore. So now we have defined the echo root, and we can load the file from our REPL. And we will do the same. And now we don't get an error, but we get 204 no content because we are not doing anything. We're responding with OK, but we're not adding any body to the response. So here again, to add body to a response, it will be, there's some Cowboy specific things that we need to know. So I will just copy and paste like a good person what needs to be done, and we will go over it. So Cowboy rec is a module that you need to read the body from the request. This is, as I mentioned, Clojure doesn't have pattern matching, and we are not using the pattern matching special form here, but it does have something called destructuring, in which you can extract values from both maps and collections, but it doesn't fail if it can't extract it. It just, these values would just be bound to nil. So we are, since we know that Cowboy rec returns OK, request body and request, if it succeeds, then we are extracting that. Then we are setting the reply with 200, an empty header map, the request body, the response body is the request body, and we provide the request. Finally, we get the request, and then we convert it into, we convert this value into an Erlang value. If we load the file again, something that I will tell you later that is useful when you do this kind of stuff, we get, well, 200, but the return value gets lost. So if we do full bar, and voila, we have something that works. So let me tell you what I mentioned before. So here, if I go up, since the REPL doesn't have history or anything, it's generally useful to wrap it around, to use RL wrap, which is a command that gives you all the things that you miss, basically. So if I do, for example, load file here, then I go up and I have history from other sessions there. So now we have a HTTP server that is working, and we don't have tests. Well, we have one test because we saw that there was a test in the test folder. No, not less test echo. We have that, but, and the way that we run it is just, as you could imagine, is a rebar3 Clojure test, but this default test is designed to fail. The reason why this is compiling Clojure again is because rebar3 has different profiles, so it's now compiling things under the test profile, not the default profile. So this test is designed to fail so that you change it. So it's asserting that 0 is equal to 1. And we are sort of running out of time. So, but I think it's worth going over how you would test this. I will copy also the example that I have from my previous session of practicing this. And here we use something that comes with Clojure, and it comes in Clojure, and it's including Clojerl, which is Clojure test, which is a namespace for testing. Basically, it defines def test, which is a macro where you can define tests. And in here, what we're doing is, in this test, we are ensuring that echo is started. And then we are making a request and checking that we're doing various requests and checking that the response is the same as the request. And the way that we're doing requests, so that we, in this case, we don't download any extra libraries for HTTP, is building a curl command, appending the data there, since OS command, which comes with Erlang, accepts lists and not binaries, then we convert the binary to list. and then we convert the list into a binary, and we compare it here. So R is a utility that allows you to define a vector of arguments, and then you specify the values here for each pair or triple or whatever number of arguments you specify here. Then you can use it in the expression that you place here. So it's a nice way of testing the same expression with different values. And if we run this now, Clojure test, we get 3 assertions and 1 test, and it succeeds. So I had another project, but I was to show you like an script, but I will instead just upload it to GitHub and share the link with you. And I've done the commits in the order that I built it, so that you can go over that on your own, and you can always send me messages if you have any questions. So we had an script countdown, and I can show you what it does. No, I deleted it. I have a different version, but you can see it later. So existing applications is that I wanted to show you that work. This Clojert application is actual OTP release that is running in a Dockerized environment, and it's deployed in a Linode. It uses WebSockets with Cowboy. So it's a nice example of how to do something that actually works and is deployed. The Docker file is there. It uses an Alpine-based Docker image, so it's very small. Then there is this project Doodler, which is for creating drawings with code. It's heavily inspired in a Clojure library called Quill, which is very nice. And Quill you can actually use online. And all these examples that you see here, they are actually taken. The code is taken from Quill and run in this Doodler. So they are compatible up to a point. So Doodler has a lot less features than Quill. And Doodler also uses protocols to either draw on a canvas, like a panel, UX panel, or OpenGL. OpenGL support is also limited because OpenGL is hard. And existing libraries that are ported from Clojure JVM, there's Clojure Test Check, which is property-based testing, and it's actually used for testing Clojerl itself and Clojure itself. There's Hiccup, which is used in Clojerl, which converts Clojure data structures into HTML. And Criterion is used for benchmarking, and it's very nice because it gives you like a bunch of different runs and estimates different statistics, and it's not just a micro benchmark of time. So I've gone very fast through a lot of things. I would like to check if you have any questions or thoughts at this point.
Could I suggest you post your questions in the chat, and then Brian will be picking people and ask you just to unmute, and so you can ask a question yourself and have that conversation. Yeah, that's worked. Okay. It worked really well last time. Yeah, is that okay, Brian?
That would be ideal.
Perfect. So
I got to say, just a comment. This is definitely the most interesting project I've seen this year, probably since Erlang, really, except going in the opposite direction. Yeah.
Cool. I'm very happy to hear that. So I have some final thoughts. If no one has any questions or questions for later, or you can reach out as well. So Clojure is kind of mature. It has a lot of the things, almost all of the features that Clojure on the JVM has, and it offers a model list running on the Beam. It makes it easy to interact with other languages on the Beam, or at least that's the goal. And if it's not, then you can always reach out and open a PR, and we can look into that. But the goal is that you don't have to start everything from scratch, and you can use libraries from other languages on the Beam to interact with Clojure. It's very close to the canonical Clojure implementation, as I mentioned before, and it makes it kind of simple, or at least possible with some work, to port existing Clojure libraries to the Beam. There are some libraries are very that rely a lot on what the JVM offers. Those are harder to implement, but the ones that aren't, like Hiccup, which is just data transformation and then spitting out HTML, is actually quite simple. This also means that it's, as I mentioned before, since Clojure is very close to Clojure, a lot of the canonical, the documentation for Clojure, so if you go to clojure.org, you can check the examples in clojuredocs.org, and most of the things will apply to Clojure as well, in conceptually and most of the time practically as well. So finally, I would like to invite you, if you're interested, and to get involved, either creating a project, and you can always ask me stuff, or contributing to Clojure itself, because there is a lot of work left around tooling and performance. It's also, even though I've been doing quite a lot around performance, it's not on par with what the Clojure JVM offers. I mean, I don't want to be on par, but at least I would like to be like 10x instead of 20. It has improved a lot. It used to be like 50, the worst comparison that I had for a specific expression, right? Not everything. So it depends on what you're trying to do. Sometimes the Erlang VM is faster, or Clojerl is faster for the same expression, but those are the less expressions. So yeah, if you're interested, reach out and give me a shout out, because help is welcome. And yep, that would be all. And thank you for your time.
Thank you very much, Juan. Did we